In this video, we will do chemical properties of acid and bases in one shot, the whole of class 10th. It says the first one we can start with a reaction of an acid with a metal, right? A reaction of an acid with metal and a reaction of base with metal. So as you can see here, it says acid reacts with metal to give salt and hydrogen gas, and base also reacts with acid to give salt and hydrogen gas. So let's take examples here. Like I can take a metal, say zinc. Zinc reacts, take an acid, say HCl, to give a product called ZnCl2, and hydrogen gas is released. Now let's take a base here. I'm taking the same base here, sorry, same acid here, and let's take a base, that is sodium hydroxide. If it reacts, it gives a base called sodium aluminate, that is Na2, ZnO2, and plus hydrogen gas is released. Now, if both of them are same, that means we remember that an acid as well as base both reacts with metals to give salt and hydrogen gas. And how it is different, therefore, or anything which is different, let's figure out. You see, most of the acids reacts with most of the metals, like those metals which are above hydrogen in the activity series, will react with this to produce hydrogen gas. But the reaction of a base, just a second. The reaction of a base is not very common. Like not all bases, right? Not all bases reacts with all metals to give salt and hydrogen gas. So it's very important that you remember these few examples. There's another metal, that is aluminum. They also react like this only. You can write down here, that is aluminum reacts with same sodium hydroxide. It's a strong base alkali to form sodium aluminate, that is NaAlO2 plus hydrogen gas. Now coming to the next we can start with reaction of an acid with, say, a metal carbonate or metal bicarbonate. It's same, right? As you can see here, acid react either with metal carbonate or metal bicarbonate. The product remains the same, but base as such does not react with metal carbonates or metal bicarbonate, also called metal hydrogen carbonate. Very important one. So we can take a metal, like say for example, acid reacts with metal carbonate. So let's take calcium carbonate, that is CaCO3. If it reacts with an acid, say HCl, it gives you three products. As you can see, what is formed here? Salt, carbon dioxide, and water. So the salt so formed is, say for example, I'm writing it below. Hold on. Yeah. So the salt formed here will be CaCl2, calcium chloride, plus carbon dioxide and water. This is the product form. Whether it's a metal carbonate as well as metal bicarbonate, same. Like for example, if it is NaHCO3, like say I've taken a metal bicarbonate this time. Let's say react with an acid. This time I'm reacting with sulfuric acid, H2SO4. The product will be same, that is a salt here, Na2SO4 plus carbon dioxide plus water. So whether an acid reacts with a metal carbonate or metal bicarbonate, the product remains the same, that is salt, water, and carbon dioxide. So you can figure out one thing, that when an acid reacts with a metal, it produces hydrogen gas. Similarly, when a base reacts with an acid, it produces hydrogen gas. But in this case, the carbon dioxide. Like in both cases, gases are produced, but this time it is carbon dioxide when it is metal carbonate or metal bicarbonate. Otherwise, it is hydrogen gas, as in case of metal. Moreover, you should also know the test for these gases. This hydrogen gas burns with a pop sound. But carbon dioxide does not burn. In fact, it extinguishes fire. We have a test for both these gases. The hydrogen gas is colorless. The carbon dioxide is also colorless and odorless gas. We cannot detect its presence. So they only can be detected with some test. So the test involved here is this carbon dioxide will extinguish fire. Moreover, it turns the lime water milky. Let's understand why does it turns lime water milky also. Whenever this carbon dioxide is passed over freshly prepared lime water, let's say I took a lime water here. I'm taking lime water, that is CaOH whole twice. This is aqueous lime water. When carbon dioxide gas is passed, what happens? It forms a precipitate CaCO3. It's a precipitate. And then water is formed. As you can see, this is a precipitate. So the lime water turns milky due to the formation of this. But another important thing that you have to remember that if you continue to pass more carbon dioxide, when excess carbon dioxide is passed over this lime water, then what happens? That it start reacting with calcium carbonate to form a new product, and this time it is CaHCO3. So the milky color will disappear because this is an aqueous solution. So this is we have done two properties of them. Let's continue with the third one. Next, we are going to do the reaction of an acid with metal oxide. Or let's say first start with this reaction of a metal with acid and the reaction of base with an acid, right? It's opposite. Huh? So you know that whether this is acid reacts with base, as you know, or a base reacts with an acid. It's all same, right? So let's take an acid, say HCl. I've taken hydrochloric acid, and if I react with a base, say sodium hydroxide, so it will give you two products, that is NaCl and water. So the general reaction involved is whenever an acid reacts with a base to give salt and water. So this is the general reaction, and this reaction so-called is neutralization reaction, wherever an acid reacts with base or a base reacts with an acid to give salt and water. This reaction is called neutralization because both acid and bases lose its character. Like acid will lose its acidic strength and base will lose its basic strength. And the solution so formed will be a salt, that is a neutral. Yeah, the product so formed will be salt, which is neutral. But remember that salt not necessarily be a neutral, depending upon the strength of an acid or a base. If there is a strong acid that reacts with a weak base, in that case, the salt will be acidic in nature. That means it will turn blue litmus red. Right. Similarly, the opposite to this is that, for example, if this is weak, right? We have a weak acid and this being a strong base, the salt so formed will be basic in nature. The salt will be basic in nature and it will turn the red litmus blue. This is what the neutralization reaction. Now let's continue with the next part. What we are left with is the last one, right? The last one is this. That is acid reaction of an acid with metal oxide and the reaction with a base with a non-metal oxide. This is left. Now, as you know that metal oxide is actually basic in nature. So whenever we react an acid, so say I'm taking an acid here. I'm taking an acid. I say I took HCl as the acid here. If it reacts with a metal oxide is basic in nature, right? So let's say I'm reacting it with calcium oxide. As it is basic in nature and this is an acid, so considering that neutralization reaction, acid reacts with base to give salt and hydrogen gas. So product remains the same, that is salt and hydrogen gas. The salt here so formed will be calcium chloride and water, sorry, not hydrogen gas, calcium chloride and water gas. Now continue with this, we have the next one. Similarly, when a base reacts with what we have left with, an acid reacts with non-metallic oxides. Acid do not react, right? Acid do not react with non-metallic oxides. We have to do with the other one, that is a base reacts with a non-metallic oxides. So let's take a base. I can take the same base, say calcium oxide, easy to compare, and I take a non-metallic oxides. So the non-metallic oxides you can take here is sulfur dioxide, right? So what will be formed here, that is a salt here will be formed. As you can see here, this is basic in nature. This is basic in nature, and this is non-metallic oxide, that is an acidic in nature. So the salt will be formed again, that is calcium sulfate. And in this case, it's a non-metallic oxide, right? With a base. So we have to take a base first, right? So let's take calcium. The base formed by calcium is calcium hydroxide, CaOH whole twice. It reacts with a non-metallic oxide. So we have to select a non-metallic oxides. We can take carbon dioxide. So it results in the formation of, say, calcium carbonate, CaCO3, which is a salt, and water will be formed. This is the reaction involved whenever a base reacts with a non-metal. This being the base, this being a non-metal, it is salt and water. So these are the categories in which chemical reactions are put in your chapter called acid bases. The first was the reaction of an acid with a metal, and a reaction of a base with a metal. The results are same, that is salt and hydrogen gas. Next, an acid reacts with either metal carbonates or metal bicarbonates. The reaction product or the result is same, that is salt, water, and carbon dioxide. And as such, base do not react with metal carbonate nor of metal hydrogen carbonate. Next is reaction of a acid with a base or a reaction of a base with an acid. The results are same. This is the reaction called neutralization. And the final one was a reaction of an acid as with a metallic oxide. As you know, metallic oxide is actually basic in nature. So the result is same here, that is salt and water. And the reaction of a base with non-metallic oxide will again produce salt and water.